Okay, so in this webinar today, we'll show the power of FormZ's subdivision modeling and 3D printing capabilities by walking you through a series of actual 3D printed projects modeled exclusively with subdivision tools and features. And these are the actual projects that we'll be covering today. So, of all the different 3D printed models we have here around the office, we decided to pick a few that were done more exclusively with the subdivision modeling tools. And so we're going to be looking at, these are the actual 3D printed models here of the models that we'll be doing in just a moment. We'll begin with this chair, sort of a simple model, and we'll get more complex as this webinar unfolds. So we start off with just a very simple cage type shape, and then we can smooth it out, and then we'll get that ready for the 3D printing process. So let's go and do that. With this chair, and this is a pretty simple example here, we start off with just a simple box, and then using the reshaping tools, we can actually sculpt that into more complex shapes. So let's make the seat of the chair itself. So I'll just offset a segment and use the reshape tool to reshape that up. And there's the backrest. And then for the side of the chair, we'll offset a couple more segments. And then using the reshape tool, push that down a little bit. So there, now we have a nice little form or cage that looks like the shape of a basic chair. Now to make this a little more comfortable, we'll go to our subdivision tools. And if you saw in the previous presentations that we have, we've gone through all the other subdivision modeling tools that are there. So we're going to go less into what these tools are doing and more and how we're going to use them in an actual workflow type of environment. So in this case, we're going to use the Subd tool. We click on the object, and of course, it subdivides it and smooths everything out for us. Now we still have the cage, so we can make further adjustments that way. And then of course we can also go back to the original cage object and edit it there also. So if I move the point of the cage, or I move a topological point of the original cage itself, then you can see I'm pretty much doing the same operation. I can switch back and forth between the subdivided and swap it back between the cage object. All right, so there's the basic chair itself. We need some legs for this, so I'm going to move that up a little bit like that, and I'm going to create the center column for the legs. Create a little shape like this. Bring that down a little bit, and there we go. Let's put the side legs here, and once again I'm going to go back to the reshaping and sculpting tools here and offset a segment. And this time when I use the reshape, I'm going to use the keep edges option. So now when I reshape this edge out, you can see that I can actually keep that edge there. So that'll help me to be able to build the other leg off of that one. And once again, I'm going to edit the cage. There's so many different ways of doing this. One method is I can just use the move tool, and I'm going to move that up and down to further reshape that. Or I can use the scale tool. So let's use a independent scale, select just the face, and then I'm going to click and drag to scale just that face that's on the end there. And then once again, I'll reshape this one out a little bit. And there we go. So we have a rough cage approximation of that leg. And then we'll do the exact same operation over here, offset a segment. We'll reshape this out a little bit. With the move tool, I'm holding the Command key on Mac or the Control key on Windows to move a point, a segment, or a face anywhere that I want. And this is just basic topological editing. This isn't subdivision modeling. This is just basic modeling tools in FormZ. And so we're going to go in and scale this thing again. And I think you get the idea of how we're getting the basic feet. Or you can actually make one of the legs and then rotate it around and copy it around like that. Okay. So now once we have that, actually I want to move that out a little bit further, don't I? So I can just grab that face and push it out a little further. There we go. So it matches the other side. Okay. All right. Oop, I'm moving it up, ain't I? Let's move it straight out a little bit. All right. So at this point, if I were to subdivide that, you can see that we have a separate object there, and there's the top chair. If we want, we can actually take and Boolean these things together. So using the union tool, I can union those pieces together to make it one single object, so that when I apply the subdivision tool, that's applied to the entire object. And you can see that transition is created for us. Now, for the bottom here, you can see that I can actually select these faces in the bottom. If I want to flatten the bottom here, I can select these bottom faces of the cage, all these little sections right here, and I can increase or decrease the sharpness there. So as I if I increase that, I can actually make that part of my cage perfectly flat for the chair if that's what I need. So now actually I'm going to fast forward here. If I were to continue on building the rest of that cage, and here's all the rest of it actually finished, it'd take me another minute or two to do that. But anyways, that gives you some idea of how we can actually quickly create something like that. Now, at that point, this first project's done. We're ready for the 3D printing process, and so we have to decide the meshing resolution that we're going to be assigned to that. Now, when we have the Subdivision tool active, and we click on that object, you can see that there's this number of iterations, and that will determine the resolution of the quad mesh that's assigned to that subdivided object. And if I were to select this as being 1, then you can see we have a coarse polygon object. We select number of iterations 2, it subdivides it even further, and 3, and so on and so forth. So you're going to want to set the iterations first, and then you can see that if you were then to convert that into a plane faceted object, if I were to select that thing and say, I want this to be a plane faceted object, you can see now that the quad mesh resolution is set prior to converting that. Okay, and there we go. That thing's ready for 3D printing. So export that out to a STL file. All right. Let's look at some other examples. If we go back to our slideshow here, let's do something a little more complex. So that chair is pretty easy, and the bottle gets a little more detail into that. And this is a neat way that we can look at how we can take a subdivision object and actually convert it into a NURBS object, and then continue to edit additional features into it as an actual NURBS object. And of course, we can add rendering effects, and we can do some cut type cross sections. We can thicken it to give it the actual thickness, and then actually get it ready for the 3D printing process. So this one will be a little bit different, because instead of a subd object being converted into a quad mesh, we have a smooth NURBS object that we'll have to convert into a faceted object for the 3D printing. So we'll look at some different ways that we can do that. All right. All right, so let's try that. Here we go. Let's go with a bottle. So once again, in this workflow, we're going to start off with just the box. We're going to use the reshape tool again to create the cage. I'm using the keep edges option, so I can actually reshape that face up multiple times, any height that I want. And you can see we have a series of loop type segments here. Now, at this point, I want to begin to sculpt the shape of the bottle. Now, I could use underlay images if I want. I could look at a front view, a side view, and as I'm grabbing these points, segments, and faces of that object, I can actually follow, maybe some kind of background underlay image if I want, or I can just eyeball it here and pretty much sculpt it into any shape that I want. All right. Another way to be able to manipulate the cage, instead of moving and scaling the faces and segments, we can also use the transform tool. So if I were to select the top face with that transform tool, there's all sorts of scaling options here. And now you can see I can actually move it and drag it around, and I can rotate it. And if I want, we can also go in and scale it. So I'll grab these arrows, scale us in a little bit over there, and maybe grab this arrow, scale that in. And I think you get the idea of how we can manipulate the different topological parts of the cage using the transform tool. So there's different ways of being able to build up that cage. So let's go back to the reshape and reshape that up a little bit. There we go. So there's the top opening of our bottle. So let's just preview this by going into our subdivision tool and looking at it at this stage, because like I said, we can very easily go back and forth between the subdivided object, and we can also use this swap option, which actually goes back to the actual cage. All right. Now at some point, I'm going to want to delete the top face here, because that will open up the bottle for the inside. I think I'll leave it closed for now. And actually, I can actually edit it now in the sub-D state by moving controls, or I go back to the cage. I'm going to create the recessed area that's in the front of the bottle here. If you look back at that image, you can see there's this recessed area, which actually gives this sort of engraved area where we're going to put this label. And so to sort of articulate that in the original cage itself, what we could do is use offset segment and just add whatever information we need, and sort of push that area in a little bit to create that recessed area. So when we convert that into a sub-D object, that recessed area will automatically be part of that object. So let's try the reshape, push this in a little bit. Same thing over here. All right. And when I push this one in, let's see, I'm going to get rid of the keep edges here. Let's push that in a little bit. And the reason I get rid of the keep edges over here is because I don't want to keep the edges as I'm pushing this shape back. Now when I do that, it gets rid of that middle edge, and I want to keep that loop seam all the way around there, so I can actually offset this edge back, snap to the end there, and so we can keep that edge of my cage going all the way around the object. So anyways, there's just a lot of different ways that you can articulate that cage. Now at this point we got that recessed area, so if we were to go into the Subdivide tool and click on it, you can see now we're starting to get that engraved area. Now it's very smooth. If you want to sharpen the contrast there, there's a couple different ways of doing that. We could actually take the cage itself and work with the sharpness sliders inside of those areas to sort of tighten those up. You can see any face or any set of edges, I can actually increase or decrease the sharpness there. Or another way of doing that would be to just add additional topological information into that cage. So if I were to offset another edge here by just maybe selecting these two, and I'm going to offset another set of edges there. I'm going to hold down the shift key to grab these two edges, offset both of those, and I'm going to make sure it inserts on there. So you can see just by, we have the same cage except we've added some additional lines here. So now when we go to the Subdivision tool, you can see we're actually getting a lot sharper crease, because as that subdivided face comes down, it has to flatten across those two parallel edges that are there. So hopefully that makes sense how we're getting that sharper crease there by adding those additional edges. All right. So anyways, if you want to bring in the bottom of this a little bit, we can use offset outline and then maybe reshape that in, and then using the transform tool, I'll select that bottom face there, scale that in a little bit, and now as we created that recessed area in the bottom, let's take a look at it again in the sub-D form, and we get something that looks like that. So now we get sort of that recessed area like you see on those bottles. All right. So anyways, I think you get the basic idea of what's going on here. I'm going to delete that top face now and sub-D that, and you see we get that opening in there. So if I were to continue on, we would end up with a cage that looks maybe something similar to this. Spend another 5-10 minutes on it, or just sitting there working with that and come up with something like this. And it's sort of a trial and error process, because you have to look at it in the cage mode. You also have to look at it in the sub-D mode. And like I said, you can switch back and forth using the swap tool here. So let's go and work more in the sub-D state now. So I'm going to actually select both of these. And this handle, you'll see what I've done here is I've actually, once I got this part of the bottle done, I just made the box, and I just sort of moved that, positioned it into place here. So that'll form the actual handle. And if I were to subdivide that, I can then use the bridge tool to bridge between two faces, or two open areas, or two edges. I can bridge between anything really. In this case, I'm going to actually select this face and that face of this sub-D object. So we really have two different objects there, and we can actually bridge it from face to face. And if you get some twisting and you don't want it to twist, then use the twist option over here in tool options, and I can actually rotate around all the different possible options to sort of tell it how to line those faces up. Now, it is dependent on where you click the faces. So if I click this face right here, and then I click on that face right by this edge over there, it'll try to match those up. Now I clicked a little more to the right, so I missed that. So I'll just go back and use a little rotate option here to further adjust that. Let's try that again here. So let's go on the bottom of this face, top of that one. There we go. So we get something that looks like that. Okay, so at this point, we have pretty much the overall shape that we want. We can further edit that object by turning on the controls of the subdivided object. So if you want to make some changes here, maybe grab these controls and push those around. If you want to do some major changes to the handle, window pick, whole sets of controls over here, and maybe move those up and down a little bit to stretch that out, and just further edit that as a subdivided object. All right. Now, if we want to convert this to a NURBS object, very easy to do. We will actually go in, and there is the convert tool that we used on the chair, and on the chair we use the convert to quad mesh. Well, this time we're going to convert it to a NURBS object. So let's see what happens with that. So all you have to do is click on your object, your subdivided object, and it actually makes a NURBS object, which is actually a network of NURBS services that are there. So now that is a NURBS object. Okay. We can use all of the modeling tools on it as we can with any other NURBS type object. For example, we want to thicken this, because if we were to look at the cross section here, we look at the clipping planes, I turn the clipping plane on, you can see it's a paper thin surface. And so we would not be able to 3D print this. There's no solid part to it. It's just a NURBS surface object there. So we need to thicken that. So we'll go to our thicken tool and let's give it some thickness. Now I'm making this sort of large, so I'm going to get some large values in here. I can always scale this down when it comes time for the 3D printing process. We're just trying to conceptualize something here. If you want to draw it, more accurate, then draw your cage to more accurate shapes. Here I'm just sort of conceptualizing the overall shape and form, and then when I print it out, I can actually give it an actual size of what I want it to be during the actual printing process. So let's thicken that. I'll click on it, and there we go. And you can see that you can use the thicken tool on a quad mesh object or on a NURBS object. It doesn't matter. It'll thicken either one, okay, to whatever thickness value that you set. All right. So with that, that's going to give it a thickness. So you zoom in a little bit here, you can see the thickness value that's been assigned to that. And maybe to better visualize that, we can turn our clipping plane on again. And once again, you can see now instead of a paper thin surface, that is a solid object of uniform thickness that was derived from the thicken tool. Now this is still a NURBS object. When we thicken a network of NURBS, it's still NURBS. And so you can see here, we still have our network surfaces here, and even on the inside, in the inside thickness, we have all of our network of NURBS surfaces. And this is one object, one solid, and this could be 3D printed. Now let's take this one step further. Sort of nice, but what if we want to articulate some more detail in here? Maybe we want to emboss or engrave some additional details into that object. Well, we no longer have our Subd controls because we converted it to a NURBS object, and so it's a more complex shape. Well, we can still do that. We can still use the normal modeling tools in FormZ, the NURBS editing tools, and all the modification tools to work on it, just like any other type of object. So let's try that. How would that workflow be for that? Well, what I could do is I could actually take and unstitch any of these surfaces that are there. So if I use the unstitch tool, I click on that face, it'll actually separate that NURBS surface from that network of NURBS surfaces that are there. So if I were to select that NURBS surface, I'm going to do an isolate operation. So I isolate everything, which is that option right there. So I can look at just this piece here, and you can see that this is a NURBS object. So I can use all the NURBS tools on that in order to get those controls. I'll use the NURBS convert to actually have access to the NURBS controls that are there, and then when I show those controls, you can now see that we have a set of NURBS controls for that face, and I can use all the features that let you edit NURBS. So I can push and pull controls and reshape it, maybe move multiple controls to put some ribs in there or something like that. Or let's put a little embossed or maybe a engraved type image into this area. So we can do that. Let's bring our bottle back, and it's still a unstitched surface, so really we no longer have a solid now. We're going to stitch everything back to at the end of our engraving operation to make sure it's a solid again for the 3D printing process. But at this point, what I'm going to do is draw a couple shapes, maybe a couple circles or whatever your logo is or whatever you want the embossment to be on there, and then let's isolate those again so make it a little easier to see. So I'm going to pick those objects and isolate. And what I'm going to do is actually slice those profiles through my object. So if I were to use slice, and I don't want to use the heal option, I just want to have those shapes just like wires cut right through my object. So the surface, I'm going to choose that one, and then it's actually split it into two. Take this surface, have this other shape punch through it or slice through it using the slice tool. And now I can delete those shapes. I don't need those anymore. And I'm going to delete this intermediate shape here. So all I end up with is this little profile there. So what I can do is take this inside surface and drop that down a little bit, whatever distance I want. So I can offset it or I can move it either way. And you can see that surface is now sort of engraved inside. And then what we need to do is create a nice fillet transition or a blended transition from the surface into this piece down here. And so we can use the blending tools, or in this case, I always like to use the tangent loft, so I can loft between any two edges of objects. So I can actually select the outer edge here of the hole that's in our surface, and then I can select this surface, which will actually use the boundary of that. And there are some tangency options over here, and we can increase or decrease the magnitude of the tangency so that it can actually flow back and remain tangent to this surface and also this surface. Now, when you click the whole surface here, it does ghost it. So I did a copy operation, so I'm going to paste that back in there. That's just the nature of the ghosting inside of FormZ standard stuff. But anyways, we have all these pieces now, and you can see if I were to do a Command A, I can actually stitch those back together, and so they actually fuse them all together, and the stitch operation is going to make that one single object now. So there we have a nice little embossed type detail that has been added into that surface. All right, so I'll go back into shaded work mode. So let's bring our rest of our bottle back. So I'll use the reveal operation, and you can see that this is still a separate face that is detached from the rest of the bottle. So all you have to do now is stitch the whole bottle with this face to be able to stitch that back in there, and now we have a solid object. This is one single object. It is a network of smooth and NURBS surfaces, and it's solid, and that'll print just fine. Okay. All right. So that's pretty much it for the detail of the bottle, but how do we actually get that thing to print? Well, the 3D printers don't understand subdivision personalities, and they don't understand NURBS personalities or smooth personalities. Of course, FormZ is this hybrid modeler that has all these different personalities. And so now we need to conform to what the 3D printer needs, and that's faceted objects. And so since this is not a subdivision object, we can't use the convert tool to convert it to NURBS because it's not a subdivision object. It's smooth NURBS. So now what we have to do is, if we select the object, you can see the attributes for the object. We can modify the display resolution. And you can see here, I can increase or decrease the overall faceting resolution, which is the faceted polygon part of smooth objects. Or I can go into this option, which we can create our own scheme, which controls how the faceting is done on that object. Now, I created my own here. If I go into the faceting schemes option, I created my own. I click the green plus button. I set this to be quads with no triangles, and I turned everything off except for the grid, so it creates like an 8x8 grid or 10x10 grid. And if I click the OK button, that'll then assign it to that. So if we look in wireframe mode, we can see that we have the dark lines, which are the iso lines, which is the smooth stuff, and we have the lighter lines, which are the actual faceting part of that actual object. Now, one thing that's sort of neat about this is the smooth NURBS objects, we don't have to convert those to export that out for the 3D printing process. I can do an export to STL now, and when I do that, the STL format can only accept facets. So FormZ will automatically use the faceted component of that smooth NURBS object when it exports it out. And when I come back to my actual project, I still have my NURBS object there. Now, if you do want to convert that over, you can do that. You can use the convert tool, and I can click on that object. I can say convert that to be faceted, and now at that point it's actually converting it. It's dropping all the NURBS parameters. Now it's just a polygon object based on the display resolution you set prior to that conversion process. Okay, so those are a couple different ways you can deal with converting your NURBS stuff into polygons that can be ready for the 3D printing process. Now, if we really wanted to see the true nature of the 3D printer mesh, we would have to put the triangulate option on. Now, I forgot to put that on in that in the display resolution, but I can triangulate it afterwards even by using the triangulate tool, and now we have nothing but triangles only. So that's actually the mesh that would be sent out to the 3D printer. All right. So that's how that more complex bottle would be created using subdivision modeling, and then also pre-processed into a polygon object for the 3D printer. All right. So let's just try a couple more examples here. What we're going to do is do this little spider clamp, which is a clamping system that's used for glass type curtain walls. And we're going to build this as a subd object, but you can see there's some mechanical type details in here. We got some holes that need to be precisely positioned and drilled, and there's some counterbore holes in there. And how do you get that type of precision out of a subdivision object? Well, let's find out. So what we'll do is we'll recreate that. We'll start off with a basic conceptual design where the only real important type of positioning is where's the location of the holes. So I actually put some guides there for the actual centerline positions. And from there, everything outside of that can be anything that I want. I can use my own creativity to actually build the rest of the clamp as long as I maintain the hole positions there. And so at this point, I'm going to use the Sub-D tool and begin to convert all these objects into a subdivision object. So it smooths everything out. And of course, we do have control of sharpness here, so if you want a little less sharp, we can get the original shape or bring the sharpness down to smooth it out. And so you can play with that sharpness value too. I'm going to keep it down to the lowest value to keep everything as smooth and organic as possible here. And we can then go to the bridge tool. I love the bridge tool. I use that constantly. And so here, I'll just simply start bridging from this face to, let's go to this one right here. See what that looks like. And then I go from this to that face. Oop, get some twisting there. So just use the twist option to change that over. Let's go across these two faces. If you zoom in close enough, you can pick the face exactly where you want it. So I'll go to the top of this face to the top of that one. And, well, I must have clicked it a little farther over. No problem. So anyways, I think you get the idea how we start to sculpt this interesting little spider fitting here. So we end up with something that looks like this. Now, the really neat thing about the subdivision objects is that we can make some drastic changes to that overall form. So if I were to go in and show controls for that, I could go in and let's say I want to raise or lower the position of where the center mount is. I can select all the controls in that area, and using the move tool, I can push that up. I can move that down, and you can see all that bridging and all that smooth stuff. Everything's all attached as one single subdivision object. Everything stays nice and smooth. All right, let's say we want to change the position of the hole openings. Well, go into a top view. Let's say we want to extend this out a little further. We can grab all those, and I think at this point you're getting the idea of how playful these subdivision objects are. All right, so, but the next step is, how do we get more machine type detail into this? Let's take it to the next level. I want accurate holes, accurate counterbore holes. I need to do some Boolean operations to machine out all of this more detailed stuff. And so what we do is we convert it to a NURBS object because we can't do Boolean operations on a subdivision object. It has to be converted to a NURBS object. And so if you do a Boolean operation on it, it'll automatically convert it for you. And so now we have the same object, it's the same shape, nothing's changed except for the fact that now instead of subdivision faces, now it's NURBS type surfaces that define that shape. And so in shaded work, you can see that better. But anyways, here you can see, I'll put this in shaded full mode. All I have to do is create a cylinder of the exact size for the counterbore hole. I do a Boolean difference and subtract that from my object. And then we end up with an actual machined feature there. So that's how we would then continue on, with the design of that item with more detail or more accurate precision type details into that object. So the subdivision modeling sometimes just is one integral part of the entire workflow for the end of that design process. All right. So that's another neat way to look at that. Now, of course, because this is NURBS, when we're ready for the 3D printing process, I would just like to go through again and say that I would have to go into the attributes display resolution and control the faceting so that when you export that out to STL or convert it to a faceted, the number of facets will be determined here, just as a reminder. All right, one last project just for fun. We're going to do this nice little table here, a very organic type structure. And you can see that if this was exclusively just NURBS, some of these appendages might be a little bit hard to create with all these transitions here. And this is where the real power of subdivision modeling comes into play, to be able to create NURBS type organic type forms with a lot of appendages and things going in different types of directions and maintain a nice smooth aesthetic shape. So let's take a look at that. So what we're going to do is look at a different type of workflow for this. Now, in the previous examples, we started with just a box, and from the box, we made a cage, and the cage was subdivided. This is sort of the same, but a different type of workflow. Follow me on this one here. This time, we're going to start with just a 2D ellipse. And if you look at the controls for that, show controls, you can see we have a major and minor radius for that thing. All right. Now I want to sort of bend this and curve it and distort it into a more complex form. So I can use the NURBS curve reconstruct tool, click on my ellipse, and I can change the degree of smoothing and the number of control points and whatever makes sense, and start dragging these controls and moving them to create a more complex shape. So if I were to continue on with that, you can see we'd end up with maybe some kind of shape that looks like this. Or we can use the deformation tools, do a radial bend and bend it through the center. There's many ways of distorting and changing that form. Now, once we have that there, we're going to actually sweep a 2D rectangle along there, which is going to sort of create the cage for the subdivision process. Now, at this point, that curve is mathematically smooth. And so if we were to sweep that now, let's try that, axial sweep. We don't really have control of how many, or the actual resolution as that source shape goes along the path. So we have a very concentrated set of faces here, and then it's spaced out a little more over there. And so we want more control over this because we're going to convert this into a subdivision object. And one general rule of thumb for subdivision objects is you don't want too many faces on there. You want big faces. You want very coarse cages to be able to articulate that form, and all of the subdivision will smooth everything out and create that nice shape for you. So let's undo and go back. I want to control the number of points on here, so I'll go to the polygonize tool, and with that I can set it to be equal length segments. Click on it, and I can convert that smooth spline curve into a polygon object, and I can set the number of segments that I want. How about 32? And because I got the equal space, there's some other options here which can control how those spline curves are converted into a polygon object. But now you can see we have a lot better distribution of the points now that it's a vector line. So if we were to axial sweep that now, the square along that path, they have nice uniform big types of polygons, and this will subdivide very well for us. All right, so all we have to do is do that same operation again to create a second one. So we get something that looks like that. So that one is dipping down a little further. And then we need to mirror and copy those. So I'll select both of those objects, use a mirror. I'm going to copy and snap right to my guide here. So now I have 4 of these there, right? So now from that first shape I have, now I have 4 of them here. So I'm ready to Boolean union these all together and convert it to a subd object to smooth everything out. Except you'll notice the intersection of where these different swept objects are coming together. We have sort of an interesting thing going on here. They're not matching exactly, so we're going to get some little splinter type facets in there and things like that. So before I union all this stuff together, I might want to clean that up a little bit. So I'm going to delete just the faces. So with the delete tool, I'm going to hold down the Command key on Mac or the Control key on Windows, and I'm going to get rid of these faces here, get rid of that object. And so this is now a surface object, and I can't Boolean surfaces, and so I need to cap off those ends. You can do that using the actual capping tool, or a faster way to cap all the ends would be to use the object doctor. Use the fix option there. I click on it and it'll automatically find those missing faces and cap all the ends so that it keeps that a solid object now. So now we're ready to grab all of our objects. We do a Boolean union, and we're going to union all those pieces together to make it one single solid, and then we'll use the subd on that to smooth everything out. So now we have this coarse cage. We use the subdivision tool on it. You click on it, and that very coarse object now becomes very smooth and organic. All right. So now what we can do, of course, we probably want to clean up some of these other intersection areas too if we want. So now we can now bridge this face with that one there. So now a little bit of twisting going there, no problem. Use the twist option there, and just keep clicking the arrow until it parades around for all the possible alignment possibilities between those two faces. So do the same thing over here. Click on those two. Oh, I didn't click them right. No problem. Just keep using the twist option for that. So there. So now we've sort of manually controlled how those pieces are going to go into there. And at this point, we pretty much just are bridging from face to face and use our own artistic creativity to sort of control, what face gets bridged with some other face there. So let's maybe put this one over there and see what happens. All right. So anyways, I think you get the idea that if we were to continue on with that, that's how we end up with our final shape form that looks like this. There you go. Let's put it in the shaded full mode. So you just got to sit there for a bit and do some bridging and create your own little nice organic table here. Now, as we mentioned previously, just as a review, we're ready for the 3D printing. This was actually 3D printed right here at the office. And in order to do that, we needed to convert this into a polygon object. Actually, we can use the convert tool, but before we do that, we really need to go to the subdivision tool, and we click on that object, and we can look at the number of iterations that we have set. And if you want to pre-visualize the actual polygon mesh, we can actually go to wireframe mode, and if inside of your display options you have the show facets on, you can actually see the actual internal facets that are there before that conversion process. So I'm going to select the subdivision tool, click on my object, and I'm going to turn those iterations down to maybe 2. And I think that should be enough there. So now at this point, if I were to export this out to a STL, it'll export those facets there. If I do want to use the convert tool on it, I can use the convert to a plain object, which then makes it just a plain quad mesh object, a nice clean quad mesh there on those. Okay. All right, and that's ready for 3D printing. Just export that out to STL. All right, well, that now concludes the subdivision modeling and 3D printing webinar. So let me do one maintenance thing here, and then I will open it up for any questions that you have.